Welcome back to Tech Insights, the podcast that demystifies complex tech concepts. Today, we're diving into a foundational principle for anyone building distributed systems, the CAP Theorem. And to guide us, we have Dr. Chen, a renowned expert in distributed databases. Welcome, Dr. Chen.
Thank you, Alex. It's a pleasure to be here.
Dr. Chen, let's start with the why. Why is understanding the CAP Theorem so crucial in today's world of cloud computing and big data?
That's an excellent starting point. In the past, most applications ran on a single server, but today, almost everything is distributed across multiple machines, often in different geographical locations. Think about global services like Netflix or Amazon. This distribution introduces inherent challenges, particularly with network reliability. The CAP theorem helps us understand the fundamental trade-offs we face when designing these complex systems, especially when network partitions occur.
So it's about making informed design choices in a distributed environment where things can and will go wrong. That leads us perfectly into the what. Can you break down what the CAP theorem actually states and what each letter stands for?
Absolutely. CAP stands for consistency, availability, and partition tolerance. The theorem states that a distributed data store can only guarantee 2 out of these 3 properties at any given time, especially during a network partition. Let's define them.
Please do.
Consistency means that every read receives the most recent write, or an error. All clients see the same data at the same time, regardless of which node they connect to. Think of it like a single, always correct version of the truth.
And availability?
Availability means that every request receives a non-error response without guaranteeing that the response contains the most recent write. The system is always up and responsive, even if it means serving slightly stale data.
And finally, partition tolerance?
Partition tolerance means the system continues to operate despite arbitrary message loss or failure of parts of the system, essentially a network partition. This is crucial because in a truly distributed system, network partitions are inevitable. You can't avoid them. So for any practical distributed system, you must have partition tolerance.
So if partition tolerance is a given in distributed systems, that means we're always choosing between consistency and availability. That's the how of it, right? How do developers and architects make this choice?
Precisely. If you prioritize consistency and partition tolerance, you're building a CP system. During a network partition, the system might block or return an error to ensure data integrity. Think of traditional relational databases or systems like Zookeeper. On the other hand, if you prioritize availability and partition tolerance, you're building an AP system. During a partition, the system will remain available, but you might read stale data. Eventually, consistency will be reached once the partition heals. NoSQL databases like Cassandra or DynamoDB often fall into this category.
It really highlights that there's no one-size-fits-all solution. It's about understanding your application's specific needs and tolerance for data staleness versus uptime.
Exactly. The CAP theorem doesn't tell you what to choose, it tells you what you can't have. It forces you to think critically about your system's priorities.
Dr. Chen, that was incredibly clear and insightful. Thank you for demystifying the CAP theorem for us today.
My pleasure, Alex.
And thank you, our listeners, for tuning in to Tech Insights. We'll catch you next time.